All right. Good afternoon. Hope everyone had a great Thanksgiving. Thanks for spending time with us today, pausing on your Cyber Monday shopping on Amazon, I'm sure. But we'll make it worth your hour. I'm Charlie Huang. I'm a senior product marketing manager at Nvidia, focused on enterprise AI. I'm joined today with Abhishek and Aman.
Hello, everyone. My name is Abhishek. I'm a product manager in Nvidia AI Enterprise team, and I work very closely with Aman and AWS teams to integrate Nvidia software within AWS services.
Hello, everyone. My name is Aman. I'm a specialist SA on the training and inference team here at AWS. Super excited for you guys to be able to see what we've been working on.
Okay, so what we have planned for you today is I'm going to go over a quick generative AI market overview, then discuss the partnership that Nvidia and AWS has together, and then Abhishek will go through our solutions and how you could build, customize, and deploy generative AI on AWS. And Aman's going to go through a demo showcasing this, and then we'll leave some time at the end for some Q&A. But first, how many of you are familiar with Nvidia? And I guess mostly games, graphics. I get a lot of, Nvidia, the gaming company. We're actually a leader in AI. If you're not familiar, we have a lot of great compute accelerators available on AWS. We've got, I think it's 4.5 million developers now. You can see the numbers here. But essentially, we're one of the leaders in AI and partnering with AWS. Basically, you have two industry leaders in AI. So just wanted to set the tone there in case you're thinking we're talking about graphics. We're not. We're talking about AI today. And here's kind of an overview of our accelerated AI infrastructure platform. I think many of you know NVIDIA as a GPU company. That is the baseline. That's where it starts. And you could see that it starts with the GPU, but it's a whole platform. And the platform isn't just GPUs. It's the networking. It's the GPU. It's acceleration comes in all forms, including the software stack. And so what we'll be talking a lot about today is primarily focused on accelerating with the enterprise AI software today. So just a quick overview. The whole generative AI boom started in 2022, just 2-3 years ago. And really, the explosion was caused by ChatGPT. It was kind of dubbed the iPhone moment of AI. And then really last year, everyone started experimenting. And this year, going into next year, enterprises are trying to figure out, how do I take what I've been piloting over the last year into production? How many of you are kind of experimenting or piloting right now? Okay, quite a few. And how many are in full production with your applications? Okay, that's a good mix. So we have something, all our solutions could help you no matter which part of the journey, but the idea is to get you into production and start making generative AI work for you. Here are some of the key use cases that we see. So virtual agents for customer service chatbot. I think that's prevalent across all industries. Code generation, so just coding, or from a marketing standpoint, doing like meeting minutes or writing blogs and stuff, that could help a lot. Just make the work more efficient. So lots of different use cases. I'm guessing a lot of you are probably doing one or a few of these. Okay, and then going into the partnership, we have a deep partnership with AWS. And kind of on the left side, you can see the infrastructure pieces, the latest GPU or compute accelerators that we offer. And it goes into kind of the service offerings as part of that platform, from DGX Cloud, NVIDIA AI Enterprise, which is our enterprise AI software suite that Abhishek will go into details on. NVIDIA NIM. How many of you have heard of NVIDIA NIM microservices? Okay, great. You'll learn a lot about that. So by the end of this, everyone will raise their hand. And then Omniverse, which is our 3D simulation digital twin, does a lot. It's awesome. I think we have some sessions on that. And then we're also integrated into AWS services. So you can see across here and how it accelerates the performance, the speed, and efficiency of these services. And then there's many enterprises that are adopting the Nvidia AI ecosystem on AWS that you can see on the right. And so I'd like to hand it over to Abhishek now to kind of go through the details of how these joint solutions are going to help you out in your generative AI journey.
All right. Thank you, Charlie. Awesome. Hello, everyone. So I'll talk about NVIDIA AI Enterprise, NIMS, and NeMo. I'll run through some slides, but we have an awesome live demo at the end, which Aman is going to present. So if I bore you all, please stay till the end to take a look at live demo. No pressure, Aman. All right. So as Charlie mentioned, we all know NVIDIA as a GPU company. NVIDIA started out as a GPU platform company targeted towards gaming, but over the years, we have evolved quite a lot. It's a full stack accelerated computing company where apart from GPU at the hardware level, we also have now NVIDIA CPUs and DPUs for specific workloads. Right? On top of it, we essentially have in the software layer 3 main pillars, the HPC, NVIDIA AI Enterprise, which I'm going to highlight and talk about today, and Omniverse, which is digital simulation and digital twin. And on top of these 3 pillars, we have higher level application frameworks, NIMS and NeMo being a part of it, but we have several different application frameworks targeted towards different use cases. So all in all, NVIDIA is not just a hardware company, but a software company as well. And I am in the software organization, and we have more software engineers now as compared to hardware engineers at NVIDIA. So without further ado, let's dive deep into NVIDIA AI Enterprise. So essentially, NVIDIA Enterprise is a production-grade software for AI from NVIDIA. We have 3 pillars of NVIDIA AI Enterprise, which is generative AI runtime. That's the focus right now. We offer enterprise-grade support with the software stack, and it is cloud-native and designed to run on your preferred services on AWS, but it can also run on-prem. So I'll dive one by one deeper into each of these. The first one is generative AI runtime. This is where I would like to highlight NIMS and NeMo. So before diving deep into it, when we talk to enterprises, they mentioned few of the challenges when they are experimenting with generative AI. Essentially, at a higher level, there are 2 main approaches that enterprises can adopt in experiencing generative AI models. The one on the left-hand side is managed generative AI services. You can think of it as Bedrock, right, which is essentially managed service. All you have to do is click deploy, and the infrastructure level details are handled by Bedrock team. You don't have to worry about which GPUs the model runs on, the latency throughput parameters of the model. It's very easy to use. You can get started very quickly, right? It's a fast path to getting started with AI. But soon you will realize that there are a lot of constraints around managed AI services. Essentially, the infrastructure on which the models run is not selectable, not customizable. That hampers the overall performance. Data and privacy is another concern that enterprise share with us around managed services, and limited control overall, right? The other approach that a lot of enterprises use is do it yourself, right? This is where we see matured enterprises who have tried and tested managed generative AI services, right, as a click-to-deploy experience. They get deeper into details for deploying and experiencing these models on their own preferred infrastructure. So in this scenario, they can run it anywhere. They can run it on their favorite AWS services or on-prem as well. They can securely manage their overall deployments. But then there are additional challenges that come with it around optimization of these models when it comes to deployment, customization and API interface, which is quite important when it comes to deployment, and also maintenance parameters. I'll just have to state it out that these are not mutually exclusive. There are situations and architectures where both of these approaches are being used by enterprises. But I'll dive deeper into the one on the right, which is do it yourself. And we have an awesome offering from Nvidia that I'll dive deeper into the next slides. So starting with inference first, because that's what we have been seeing with enterprises. They start out with testing out these models, checking out the API interface, checking out the latency, throughput, and accuracy performances of these models. So that's where NVIDIA has to offer NVIDIA Inference Microservices called as NIMs. NIMs is an accelerated runtime for the models. I'll come to the models in the next part, but essentially it's a containerized microservice application that you can easily deploy on your preferred AWS service or on on-prem infrastructure as well. It's a pre-built container with a pre-built Helm chart that makes it super easy to deploy. It is based on standardized industry APIs, so we have adopted OpenAI schema for all the models that we support within NIM. And you can deploy customized models as well. All in all, 3 value props, which is it is super easy to deploy, gives you the best latency and throughput performance out of the box, and it has a consistent API across different modalities. So not just specific LLMs that you want to deploy, but other models as well have the same API schema. And all of this goodness is included within NVIDIA AI Enterprise that gets you started super quick on these models. So we have NIMs for not just LLMs. LLMs is the focus right now, but other modality models and vertical-specific models as well, which include VLMs, which include digital human models, simulation models, which also include biology and healthcare-specific models. All of these are kind of NIMified, so it is guaranteed that it runs the best, with the best throughput performance out of the box on top of NVIDIA GPUs. So not just LLMs, we support other models and other modalities as well. What is available today? So we have more than 100 plus preview NIMs. I'll come to preview NIMs in the next slide. But we support most of the community models out there as NIMs, right, which range from different verticals and different modalities. But on the right-hand side, you can see we have 30 plus downloadable NIMs available today. These comprise of the famous meta models, the Mistral models. There are NVIDIA original models as well, and we have some announcements coming up super quick tomorrow and day after around those. And we have embedding models, retriever models, as well as NIMified downloadable models. So one essential difference here is you can download these NIMs from NVIDIA, and you can deploy it on your services. So next slide just essentially showcases the high-level overview. You can right now as well visit build.nvidia.com. This is a page where we have designed it to be like a developer experience page for experiencing NIMs, right? On the left-hand side, you can see there is a hosted API interface. This is running on NVIDIA Compute, but it is meant to be used as a test or prototyping experience, right, for getting responses from these hosted API endpoints. We have a bunch of models supported there. It's great for rapid prototyping. You just have to create an account and get started quickly. This will give you best latency throughput out of the box, but it's not meant to be used in your production workload. It doesn't have an attached business SLA to it. It is tagged as preview on build.nvidia.com. Whereas on the right-hand side, you can see an experience. There's a tab called Docker. As mentioned before, NIMs are containerized, right? So it's available as a downloadable Docker container. You can essentially download this Docker container and deploy it on your infrastructure. It's packaged with all the NVIDIA goodies that are available in the open source world, as well as customized specifically for NIMs. You can deploy it on your local host. You can deploy it on your EKS cluster, for example, or on SageMaker, and get started quickly. All right, this is one of my favorite slides. It showcases the breadth of the support for the models that are NIMified, right? So we work with different model providers out there. All of them, if not most of them, if not all of them. But we NIMify their model. We make it super easy and super efficient to run on top of NVIDIA GPUs because it's important to provide best latency throughput performance out of the box. As we all know, NVIDIA GPUs are quite costly these days. But essentially, you can download these NIMs and deploy it on EC2 or EKS or SageMaker just out of the box. All right, so one might ask a question, who is this NIM for? Right? Essentially, we have two target personas in mind when we design NIMs. The first one is enterprise application developer. These developers are the ones who are essentially going to integrate and use the deployed NIMs right, within their applications for developing their applications. So this persona prefers using like open source foundation models with their latest, greatest abilities, right? Example, agentic abilities, right? Coming up in open source models. They care about scaling these models and using it in the most efficient manner, right, within their application as their application scales. And they prefer deploying it on their own infrastructure with specific GPU SKUs. New GPUs are getting available pretty quickly. We have Grace Blackwell GB200 coming up on AWS soon. So they care about getting the best performance out of the box, right? So deploying on their custom infrastructure and also getting the lowest latency and highest throughput once the model gets deployed. The second target persona is IT DevOps. Because NIMS is containerized and we have a Helm chart, you need a DevOps persona to deploy it in the most optimum manner on your cluster. NIMS is containerized and microservices architecture, so it's loosely connected. It can be easily deployed. The API is a standard OpenAI schema, so to change the model, all you have to do is just change 3 lines of code, and the API stays the same, right? There is enterprise SLA with downloadable NIMs. So we stand behind these downloadable NIMs and the performance that it has to offer on NVIDIA GPUs. And it can be deployed on specific targeted GPUs to get the best performance out of the box. One important point is it also exports cloud-native metrics, scaling metrics, that can be leveraged for scaling out the deployment as the application scales. All right, diving a little bit deeper, NIM is containerized. We have model-specific containers that have model-specific optimizations built into it. Essentially, we do 2 levels of optimizations. I'll come to the optimization part in the next slides. But essentially, there is runtime optimization and there is model-level optimization. All of these are built into the container as well as the model artifacts that come with the NIM. When a model container is launched, the container itself figures out which hardware configuration you are running it on. It detects the hardware, for example, P5 instance, right, with H100 GPU. It caches and loads up the model artifact which has been optimized for P5 instance. It selects the most optimal parameter for that hardware and loads up the model quickly. So all you have to do is just Docker run to test it out, right, on a P5 instance, for example, and the container figures out everything by itself. The optimizations like in-flight batching has been built into the container. It leverages TRT-LLM and VLLM under the hood. And there are model-level optimizations like layer fusion and quantization and precision that makes it super fast to run, gives you best latency throughput out of the box. This is one click deeper into the NIM architecture. So client side, it has the OpenAI schema. It's same for all the models that we saw before and different modalities as well. We leverage fast API under the hood for exposing this OpenAI compatible schema. And there are a bunch of standard APIs that you can hit, which are chat completions and models health ready, which are cloud native and can get you started quickly in terms of deploying on clusters, right? But the essential part is the LLM executor. That's the brain of NIM. So it figures out the hardware configuration under the hood, like the GPU type, the memory available, the number of GPUs, and bunch of lower level infrastructure details. And then it selects the optimal runtime for a specific model. So either it selects TRT-LLM runtime, which is super fast, super when you deploy it, it gives you the best latency throughput out of the box, or it selects a VLLM runtime based on certain configurations. So all this intelligence is built within that container itself. Just a higher level overview on the optimizations that we are doing within each of these containers. So we scan through multiple different dimensions, multiple parameters like GPU architecture, whether we are building a model engine for A100, H100, A10G, for example, right? The number of GPUs that can be supported for a specific model. So in this diagram, there is a Llama 3 8B instruct model, and we are running through different dimensions. Plus, there are more. These are just high level, for which we can optimize and run most efficiently on top of NVIDIA GPUs. So number of GPUs available, the optimization profile that can be selected. So either throughput optimized or latency optimized, right? And the precision that can be supported on that specific SKU. On the right-hand side, you can see the optimized models listed here. So it's just Llama 3 8B, but different model engines for different hardware configurations, right? So these are pre-built. You don't have to build it by yourself. It's pre-configured. It's ready to be deployed. All you have to do is just run the Docker container. It figures out the configuration and downloads an appropriate model from NGC, which is our model hosting platform, and runs it super quickly. Another example, very similar, but Llama 3 70B. In this case, 70B is a huge model, doesn't run on 1 or 2 A100s, needs at least 4. But all these configurations are pre-selected. You don't have to think about how many GPUs are needed and what configuration needs to be selected. The container itself figures out and runs it quickly. Awesome. There is a quick demo. I've been talking a lot about performance. Let's see whether this works. Yes. So on the left-hand side, you can see NIM off. This is a chat interface, right? This is running a Llama 3 8B model. On the left-hand side, it's the same prompt, right? On the left-hand side, it's the model out of the box without any optimizations. And on the right-hand side, it's NIM on, where it's the same model. It's running on the same compute infrastructure, but it's running as a NIM, right? So you can literally see the difference in the performance. So in this case, we achieved like a 6 times performance gain when the model was deployed on that compute. One of the wins with one of our customers was Wiz. Wiz is a cloud security company. They are developing a platform called DSPM, right? Data Security Posture Management. And they leveraged Llama 3 NIM microservices, right, for their deployments. And they saw 2 times better performance on their configuration, right, out of the box, right, without any tweaking. Out of the box, 2 times better performance than running the model as it is, right, and 25% better than the best VLLM open source library out there. So it's a nice win. We have been closely collaborating with them. And they are interested in multiple NIMs, not just a single Llama 3 NIM, but other models as well, which is very easy to use and deploy and switch as well. All right, so a lot was said around one specific NIM, just an overview about the architecture and stuff. But now we also have something called AI blueprints. Blueprints are reference architectures which stitch multiple NIMs together, and Aman is going to show one of the blueprint sample use cases at the end. But these are sample applications that leverage NIMs under the hood. You can customize it as per your deployment scenarios and quickly get started solving for a specific use case. So we have a bunch of these already GA out there. Digital Human, you can check it out on build.nvidia.com as well. It's super cool. Digital Human that leverages a RAG under the hood. There is multimodal PDF extraction, which seems to be quite popular. Most of the enterprise data that we talk to with enterprise companies is in PDF format. So if you want to chat with your PDF, you need to extract that data. So there is a blueprint for it to showcase how NIMs can be leveraged within it. Virtual drug screening, which is healthcare specific, and vulnerability scanning as well. This is super cool, already available today. We have a GitHub repo. Resources will be shared at the end. But essentially, it's overall AI blueprint. We are partnering with SoftServe, which is one of our software delivery partners, and they are leveraging these blueprints and NIMs to create use case specific applications leveraging generative AI models and leveraging NIMs under the hood. They are targeting bunch of different verticals and bunch of different use cases, and we are working with them closely to have these open sourced and published out on GitHub as reference code as well. All right, so we talked about this inference side of things, right, which is mostly the NIM and NIM agent blueprints or AI blueprints, right? But in this AI flywheel domain, right, it's not just inference. Once you start with inference, once you start testing the model accuracy and its performance on generic data, it seems good, but enterprises soon realize that they need to customize the model for getting correct responses on their proprietary data. So that's where we have this overall AI flywheel, where you need to customize your model deployment and, of course, maintain the model performance, right, as time passes, addressing different issues like data drift or model drift, right? And you need to customize it as a data flywheel. So NVIDIA has to offer not just the inference part, which is NIM and blueprints, but we are also working hard on the customization story as well, right from curating the data, deduplicating the data, and making it ready for customizing the models. We have a bunch of solutions currently under private preview, but soon to be GA for customization. So I'll just go to the next slide just to showcase with our closest partners, we are working on NeMo Customizer. NeMo framework is already available on GitHub out there. It's been GA for a while. You can check it out today as well. It's mainly used for large-scale training of your model or customization of your models on distributed clusters. NeMo Customizer microservice is something that we are working on to make it super easy, just like NIMs, to make it super easy to do customization, right, of Gen AI models on NVIDIA GPU clusters. So today it supports LoRa, p-tuning, SFT, and DPO. We are extending the support for other techniques as well. But essentially, it's super easy to use out of the box. You just have to do 1 or 2 API calls to kickstart your model customization. All the underlying dependencies are taken care of by the customizer microservice itself. And on the right-hand side, you can see the training time reduces considerably. Just as we had NIM off, NIM on, here customizer off on the left took about 28 hours for customizing Llama 270B. This is an old result. But with customizer on, we have 2 times faster customization done, right, using NeMo Customizer microservice. So super excited around this. Stay tuned. It's soon to be GA in first quarter of next year, but stay tuned for it. All right, coming back to NVIDIA Enterprise, the first pillar was generative AI runtime. Second one is enterprise grade. I'll just high-level touch base on this. We have something called top of the tree monthly release. We all know this field, generative AI, is moving at a rapid breakneck speed, right? And things keep changing at a rapid pace, but that also results in breakage of a lot of APIs, right, as we go along. So top of the tree is meant to be latest, greatest, but it doesn't guarantee API stability. Whereas a lot of enterprises that we talk to want stability when it comes to deploying in production, right? That's where we have, at the bottom one, the production branch, where we have 2 stable branches for NIMs and NeMo, right, which are stable for a period of 9 months. So no API changes or breakage within these 9 months. We'll have monthly CVE patching, so any security vulnerabilities will be removed, but the API remains the same. And there is a 3-month overlap between these 2 branches, right? So you have ample enough time to switch over to a newer branch with newer features, right, within this 9-month period. There is also SBOM, which is a software bill of materials, so what's packaged in that container is also shared, and also a VEX report, which gives remediation guides and more to resolve any CVE issues. So all of this is included within NVIDIA AI Enterprise. All right, last one, it's cloud native, designed to be deployable on EC2, EKS, SageMaker. We support a bunch of NVIDIA GPUs within the optimized profile, but we also strive hard to support the older generation like T4 and V100 GPUs as well, right, with this deployment option on AWS. So all in all, NVIDIA AI Enterprise is the production-grade software for deploying generative AI. Right? You can deploy it on your preferred AWS services. You can get started quickly. There is a trial license as well, so you need not worry about free trial usage. And it's supported and has a business SLA associated with it. Just one last slide, I think, from my side is we are releasing these NIMs available on AWS Marketplace. It's available today as well. These are ready to be deployed from AWS Marketplace on SageMaker, right, as a click-to-deploy experience. You can get the best latency throughput, as explained before, right? Out of the box, we have made it super easy to deploy on SageMaker as well. There are code samples available. So you can get started today and experience NIMs on AWS. All right, a bunch of GPU SKUs that we support with the NIM and NeMo customizer. The latest one is H200. You can test out the performance. Only issue is access to GPUs, quite difficult to get these days. But after this one, I'll hand it over to, one last slide. This is just to showcase the overall deployment scenario. The one on the right-hand side, right, it showcases the available services on AWS where you can deploy NIMs and NeMo. You can deploy it on EC2, EKS within your own VPC, right? You can deploy it on SageMaker as well. Make it super easy to deploy and super easy to use. But all in all, this is our AI Foundry for custom LLM from NVIDIA, which comprises of NIM, NeMo, and the accelerated runtime, the infrastructure, right, on AWS. Awesome. So demo, handing it over.
Awesome. Thanks, Abhishek. Once again, my name is Aman. I'm a specialist SA on the training and inference team here at AWS. I know Abhishek has been building y'all's hopes up for the demo, so hope it lives up to your expectation. Quick question, who's hungry? I'm hungry. Should we order some pizza? I think let's do it. But you know what? Instead of doing it the normal way, let's use NIMs to do it. So we've built out this really cool blueprint that Abhishek was talking about. And we've used Amazon EC2 to be able to build out this demo. Now, specifically, actually, you know what? Let's go through it. So on a normal day, if you're hungry, the way you'd order a pizza is you'd call the pizza restaurant. There'd be someone on the other end that answers the phone. And you'd have kind of a back and forth on what kind of pizza you want, what kind of base you want, et cetera, right? So what we've done is we've kind of eliminated the human being on the other end, and we've kind of replaced it with NIMs, a collection of NIMs. So we've got 3 different NIMs running. So let's go through it step by step, right? You'd call a number using VoIP, or Voice over Internet Protocol. We use Twilio, which is available on the AWS Marketplace. And your audio stream, whatever you say to the number, would actually get routed to a load balancer. And that load balancer would then forward it to something called a Twilio server. Now, the Twilio server uses something called TwilML in the backend, and that essentially just spins up an HTTP server and a WebSocket server in the backend. Now, say, for example, you say, I want a medium pizza, right? So that gets forwarded by the load balancer as gRPC traffic straight to your EC2 instance. OK, so now what's happening inside the EC2 instance? So first things first, we're using a single G6C.12x large to be able to support 3 different NIM. Okay, and obviously, you have an auto-scaling group to be able to scale your deployment as you go. But let's talk about what's inside it, right? Your 3 NIMs. Like Abhishek mentioned, you can use a simple Docker run to be able to instantiate a NIM, right? So again, let's take the example. Let's say you said, I want a medium pizza. That gets forwarded as gRPC traffic to your EC2 instance. And you hit your first NIM, which is your ASR NIM, which you might have seen on one of the slides that Abhishek had up. So ASR is automatic speech recognition. And specifically, we use the parakeet Riva NIM here. Right? So what the NIM essentially does is that it accepts an audio stream via gRPC traffic, and it will transcribe that audio for you. Right? So if you say, I want a medium pizza, it will take that in, process it, and then push it back back to the Twilio server as transcribed text. Okay? So now you have just a bunch of text in your Twilio server that says, I want a medium pizza. You need some sort of central processing unit to be able to actually make sense of what you said and take it to the next step, which is toppings or whatever you fancy. Right? So that's where the LLM NIM comes in. So for this particular deployment or the demo that I'm going to show you, we use the Llama 3.18b NIM, mostly because it's small and also because we could set up tool calling. I'm not going to go too much into the specifics of the tool calling that we set up, but essentially what we did is we have a function defined within it where where it takes you step by step through the pizza ordering process, right? So you want this base, you want this topping, et cetera, right? So again, so you said I want a medium pizza. It goes to the ASR NIM, comes back as text, and then that's sent as an HTTP request to your Llama 3.1 NIM, and then that comes back as text. Remember, you're still calling a number, so you still want to hear audio on the other end, right? So that's where the last NIM comes in. That's the TTS, or text-to-speech NIM. So whatever was the response from the LLM NIM would then get sent to the text-to-speech NIM, and that's what you hear on the other end, right? So that's the whole story of how this demo was pretty much deployed, right? Essentially, you speak to a number, and you have a back and forth with a bot rather than human being. I think it's better demonstrated if I do a live demo. So let me get my phone out, and I'll call a number to order a pizza. Let's do that.
Welcome to our pizza ordering service.
Is that audible?
How can I help you order a delicious pizza today?
Hi, can I get a medium pizza?
We have medium pizzas available. What kind of crust would you like? Thin, thick, or pan?
Can I get a thin crust? Don't feel like sharing today.
I think you might need pineapple. We have pineapple as a topping. Would you like to add pineapple to your medium pizza?
Sure. Let's add pineapple to the medium pizza.
So, to confirm, you'd like a medium pizza with pineapple as a topping. What about the crust? Thin, thick, or pan?
Can I do thin crust?
I think you meant to say thick crust. We have thick crust available.
I'll share.
Would you like to add any other toppings to your pizza, or is it just pineapple and a medium size?
I think that's good.
So, to confirm, you'd like a medium pizza with a thick crust and pineapple
Does that
as
sound
a
good?
topping. Is that correct?
Delicious.
Yeah, that sounds good.
Thank you for your order. Your pizza will be ready soon. Bye.
Bye. So remember, NIM is super fast, so it will take whatever you say really, really quickly, and it'll keep going. But yeah, it's a quick demo. You can still tune the LLM NIM however you want to, add custom tool calling however you want to, and yeah, it's super customizable as well. I'll pass it back on to Charlie, take you through the last few slides. Thank you.
Yeah, very cool, huh? And how long did that take you to build? Pretty quick, right?
Yeah, we had quite a bit of help from our end, but yeah. Super quick to deploy, like Abhishek was mentioning.
Yeah, so just like based off one of these blueprints, you add your own pieces, and you're able to build a whole application like that.
Right, exactly.
So I think coming out of this, the next step, if you want to learn more or talk to some experts, Nvidia has a booth on the demo floor. I think it's open later today. It's booth 1620 if you work by numbers. Otherwise, just look for the big Nvidia sign hanging from the ceiling. Come talk to us. I think you all got scanned on the way in, but that way we could be in touch that way. There's a lot of ways to experiment on what we talked about today. Specifically, if you want to play yourself with what Aman just showed, it's actually on GitHub. So you can see the URL at the bottom there. But go ahead and go try it out yourself. It's available there. If you scan the QR code, it takes you to our API catalog, what Abhishek talked about. So there's like hundreds of different NIM microservices or these different models that you could try out in the preview mode. And there's a number that could be downloaded and deployed in AWS. Or just today, I didn't put it here because it's hot off the press, but we have those 4 different NIM microservices available directly in the AWS marketplace to deploy directly on SageMaker. There is NVIDIA Launchpad. So if you don't have too much time and you want just kind of a lab setting, we have these labs where it gives you instructions and you could walk through these different generative AI applications and scenarios to get a feel for how to play and develop some of these applications and use the NVIDIA software. So there's that. And then Abhishek also mentioned a 90-day license that's available for NVIDIA AI Enterprise. So if you're ready to dive in, just search for NVIDIA on the AWS Marketplace, and all of this will come up, and you could get started right away. Yeah, and this is what we have for you. Thanks so much for joining us today. Come visit our booth. We'd love to talk to you. Thank you. Enjoy the show.